Hey champs of Examsnet, welcome to the question series of Examsnet. Student, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because here you will find so many entrance exam question papers along with their detailed PDF solutions, and you must download our app. The link is available in the description box for better preparation of your exam. So today, students, we will be solving JEE 2024 30th Jan Shift 2 paper. In this particular video, I will be solving physics part of the paper. So here we go. Let us start with the first question of the physics part, that is question number 31. If 50 vernier divisions are equal to 49 main scale divisions of a traveling microscope and one smallest reading of main scale is 0.5 millimeter, the vernier constant of traveling microscope is. So student, this question is from the chapter of units and measurement. So according to this question, we have to find the vernier constant of traveling microscope. Vernier constant means we have to find the least count of the traveling microscope. Okay. Now according to question, if 50 vernier divisions are equal to 49 main scale divisions. Okay, student, in a vernier caliper, the vernier caliper or the vernier scale is used to measure the least count of the device. Okay. So it is used to measure the least count, basically used for the measurements, taking the dimensions of that instrument. Okay, whatever we are using. So vernier caliper is used to determine the measurement. So in this question, we have to find the least count of the traveling microscope. Okay. So in a traveling microscope consists of a vernier caliper. Whatever we have to examine in the microscope, we examine it with the help of the vernier caliper. Okay, so we have to find its least count. In vernier caliper, there in one side there are main scale divisions, vernier scale divisions, and of the traveling microscope there are main scale divisions. Okay, so according to question, 50 vernier scale division are equal to 49 main scale division. Okay, means one vernier scale division is equals to 49 over 50 main scale division, and according to question, one smallest reading of main scale is what? 0.55 millimeter. Means one vernier scale division is equals to 49 over 50 into 0.5 millimeter. Okay, now least count, we have to find the least count. So least count is equals to 1 main scale division minus 1 vernier scale division, and 1 main scale division is equals to 0.5 mm minus 1 vernier scale division means this. So 0.5 into 49 over 50, so it will be equals to 0.5 minus, taking 0.5 common, so it will be equals to 1 minus 49 over 50. So it will be equals to 0.5. 50 minus 49 means 1 over 50. So it will be equals to 0.01 millimeter. So the least count of this vernier scale is vernier constant of the traveling microscopics 0.01 millimeter, means option D is correct. Okay. Now next question 32. A block of mass 1 kg is pushed up a surface inclined to horizontal at an angle of 60 degree by a force of 10 Newton parallel to the inclined surface as shown in the figure. When the block is pushed up by 10 meter along the inclined surface, the work done against the friction force. We have to find the work done. So this question is from the chapter of work, energy and power. Now, according to question, we have to find the work done, okay, against the frictional force. So, in such type of question where the this uh, mu is given and mass is given and the angle is given, okay. So, in such type of question, to find the work done, we used a formula: work done against frictional force is equals to mu mg cos theta into displacement, means how much the block is displaced, okay, into s displacement. So mu, here mu is frictional constant, is 0.1, mass is 1 kg, gravity is 10, and cos 60 into s is what? It is displaced by 10 meter. So it will be equals to 0.1 into 10 into 1 by 2 into 10. 2 5 is 10. So it will be equals to 0.5 into 10, means it will be equals to 5 joule. So the correct answer is option B, 5 joule. Now next question 33. For the photoelectric effect, the maximum kinetic energy Ek of the photoelectrons is plotted against the frequency V of the incident photon as shown in the figure. The slope of the graph gives, okay. Since this is from the photoelectric effect, what is photoelectric effect? In photoelectric effect phenomena, the photons of a sufficient frequency falls on the surface of the metal, and when it falls on the surface of the metal, gamma photons, the electrons are ejected from the surface of the metal. These ejected electrons are called photoelectrons, okay. These electrons are called photoelectrons. So the kinetic energy of these photoelectrons is equals to initial kinetic energy minus work function. This work function phi is equals to hc over lambda, okay. hc over lambda, and this initial kinetic energy is what? H nu is the frequency, minus phi is the work function. So comparing it with the slope equation, line equation, y equals to mx plus c. So here m is the slope, so comparing this equation with this, we get the slope m is what here? H. So whatever be the slope, it will be equals to the h is what? Planck's constant, okay. So according to question, we have to find the slope of the graph. So the slope of this graph is the Planck's constant, means our correct option is option D. Now 34th question. A block of ice at minus 10 degrees Celsius is slowly heated and converted to steam at 100 degrees Celsius. Which of the following curves represents the phenomena qualitatively? Okay. So this question is from the chapter of kinetic theory of gases. So according to this question, at first, let us say this is heat supplied and this is temperature, okay. So at first, a block of ice of at minus 10 degrees Celsius is slowly heated. Let us say this is minus 10 degrees Celsius. The block of ice is slowly heated when the temperature rises. So the ice is heated and it reaches to 0 degrees Celsius. Okay. Now at 0 degrees Celsius, it starts melting, and when it is again heated, so there is a rise in temperature and it reaches to what? 100 degrees Celsius, and after 100 degrees Celsius it start vaporization. The vaporization process start, means it's now converted into steam, okay. So at these 2 points, this and this, there will be phase transition, and at 2 points, there will be phase transition, and at 2 points, this and this, there will be slopes. Okay. Now, comparing these graphs with the given graphs, we see that the option D is the correct answer. Okay, if we compare, since we can also take it starting from the origin point. At first when the temperature rises, it is like this, then it start melting, then again when the temperature rises, goes to 100 degrees Celsius, then it start converting into steam. So this and this is the change in phase, and these are the slopes. So option D is the correct answer. Now next question. Question 35. In a nuclear fission reaction of an isotope of mass m, three similar daughter nuclei of same mass are formed. The speed of a daughter nuclei in terms of mass defect delta m is. So this question is from the chapter of atomic and nuclei. So according to this question, in a nuclear fission reaction, an isotope of, let us say the isotope is X, it is converting into three parts, three daughter element y plus z plus p. The nuclear fission reaction occurs, and it is the due to the fusion reaction, it breaks down into three parts, y, z and p, each having a mass. Let us say its mass is capital M, so their mass will be m by 3, m by 3 and m by 3, each having same mass. Okay, so we have to find the speed of the daughter nuclei in terms of delta m mass defect. So its mass will be delta mc square is equals to half mv square, means half m by 3 v square plus half m by 3 v square plus half m by 3 v square. Okay, now this delta mc square is equals to 3 by 2 into m by 3 v square. This 3 cancels out. So delta mc square will be equals to 1 by 2 m v square, or v square is equals to 2 delta m c square over capital M. So v, speed of the daughter nuclei, is equals to c under root 2 delta m over m. This is our final answer. So speed is equals to c 2 delta m over m. So the correct option is C. Now next question 36. Choose the correct statement for the processes A and B shown in the figure. So this question is from the chapter of kinetic theory of gases. Kinetic theory of gases. Okay. Now according to this question, we have to find whether the process A is adiabatic or isothermal or what. Okay. Now, since we know a famous graph, like if this is volume, in y-axis there is pressure, so we have seen normally this type of graph, like this. In such type of graph, this is adiabatic process and this is isothermal process. Okay, now if we extend it like this, okay, this is same as the given graph. So this is, let us say A, this is B. So this is what? Isothermal, and this is adiabatic. So for adiabatic process, always PV gamma equals to constant, and for isothermal process, PV equals to constant. So the process A represent PV equals to constant, and the process B represent PV gamma equals to constant. So its correct option is option A. Now next question, question 37. An electron revolving in the nth Bohr orbit has a magnetic moment mu n. If mu n is directly proportional to n raised to the power x, the value of x is. Okay. So this question is from the chapter of atomic and nuclei. So according to this question, an electron is revolving in the nth Bohr orbit, we have to find its magnetic moment. Since the magnetic moment moment is equals to what? I into A, current into area, okay, and it will be equals to I into area is what? Pi r square, okay, and I is what? Charge over time q over t into pi r square, okay, and t is what? Circumference over v into pi r square, ठीक है. तो magnetic moment is basically mu is equals to qv over 2 pi r into pi r square. So q pi cancels out each other. So mu is equals to qv and r cancels one power. So qv r over 2. So it is basically proportional to v into r. And we know that in Bohr's quantization process, the V is equals to velocity is equals to 2 pi k z e square over nh, and the radius is equals to n square h square over 4 pi square m k z e square, okay. So from this, the magnetic moment mu is directly proportional to V is what? Z over N, and R is proportional to N square over Z, okay? N square over Z. So Z cancels out. So mu and N cancels one power. So mu is directly proportional to N, means N raised to the power N. So the value of X here is 1, okay? Now next question, 38. An alternating voltage Vt equals to 220 sine 100 pi t volt is applied to a purely resistive load of 50 ohm. The time taken for current for the current to rise from half of the peak value to the peak value. So this question is from the chapter of current electricity. Now, before solving this question, let us first recall in SHM motion. Whenever we do SHM motion question, so here is the origin O, here is, let us say, uh, A naught by 2, and let us say here is A naught, okay. So in such type of question, this time is t by 12 and this time is t by 6. So we have to do the same in this question also. Let us say this is point origin O. Let us say this is I naught by 2 and this is peak value I naught. So we have to find the time taken for the current to rise from half of the peak value to the peak value. Means the time here is t by 12 and here the time is t by 6, okay. So t time will be from half of the peak value to peak value. The time is t by 6, so time will be equals to t by 6, and t is what? T is 2 pi by omega, so it will be 2 pi by omega into 6, okay. It is equals to 2 pi, and omega is what? The equation is given as what? Vt is equals to 220 sine 100 pi t. It means, comparing it with the standard equation, Vt is equals to V naught sine omega t. V naught sine omega t. So here omega is what? 100 pi. So now putting the value of omega here, 100 pi into 6. So it will be equals to pi cancels. 2 3s are 6. So t will be equals to 1 over 300 second, means t is equals to 3.3 millisecond. So our correct answer is t equals to 3.3 millisecond, means option B. Okay. Now next question, question 39. A block of mass m is placed on a surface having vertical cross section given by y equals to x square by 4. If coefficient of friction is 0.5, the maximum height above the ground at which block can be placed without slipping is. We have to find the maximum height. Okay. Now this question is from the chapter of kinematics. According to this question, they are having vertical cross section given by y equals to x square by 4. Let us draw the graph of y equals to x square by 4. Let us say this is the graph of y equals to x square by 4. Okay. When the block of mass is here, let us say at a starting point the block of mass is here. So at this point its slope is less. Okay. Now when it is at point here, its slope is more. So let us say the block reaches at a sufficient point at which it starts slipping. Slipping, okay? The slipping starts. So when the slipping process starts, at that point, the slope tan theta, it will be equals to mu, coefficient of friction. And we know that the slope is given by dy by dx. It is equals to tan theta. Okay. Since and it will be equals to mu. This is the famous relation. Okay. So y is given as x square by 4. So dy by dx will be equals to 2x by 4 means x by 2. So from this x by 2 will be equals to mu, and mu is given what? 0.5. So mu means x by 2 will be equals to 1 by 2. So x will be equals to 1. So from this y is equals to x4 by 4 means 1 raised to the power 4 by 4. It means y equals to 1 by 4. This implies that the height is equals to 1 by 4. Okay. So the correct answer is h is equals to 1 by 4 meter means option A. Now next question 40. If the total energy transferred to a surface in time t is this 6.48 into 10 to the power 5 joule, then the magnitude of the total momentum delivered to this surface by for complete absorption will be. So this question is from the rotational motion chapter. Rotational motion chapter. Okay. Now according to this question we have to find the total momentum. Since we know that the energy is equals to P into C, the relation between energy and momentum equals to PC. So P will be equals to E by C, and energy is given as what? 6.48 into 10 to the power 5 joule over C. C is what? 3 into 10 to the power 8 meter per second. Now solving it, we get 2.16 into 10 to the power minus 3 kg meter per second. So our correct answer is 2.16 into 10 to the power minus 3 kg meter per second. Option B is the correct answer. Okay. So the next question is 41. A beam of unpolarized light of intensity I naught is passed through a Polaroid A and then through another Polaroid B, which is oriented so that its principal plane makes an angle of 45 degree relative to that of A. The intensity of the emergent light is. So this question is from the chapter of wave optics. According to the question, there are two polarizers A and B. Let us say this is polarizer A and this is polarizer B. Okay. The unpolarized light comes from this direction and it goes after passing through polarizer A, it goes through the polarizer B. Okay. Now, when it emerges from the polarizer A, at that time its intensity is I naught by 2. Okay. At first, it is the unpolarized light. It is of intensity I naught. After passing through the polarizer A, its intensity becomes I naught by 2. So the question is asking about the intensity of the emergent ray that is passing through the polarizer B. So when the light ray passes through polarizer B, according to question, it is making an angle of 45 degree. Okay, so its intensity will be I equals to this, I naught by 2 cos square theta. Okay, here theta is what, 45 degree, so it will be I naught by 2 cos square 45 degree. So it will be equals to I naught by 2 into 1 by 2. Since cos 45 is 1 by root 2, so 1 by root 2 whole square will be 1 by 2. So the intensity will be I naught by 4. So our correct answer is option A, I naught by 4. Now next question 42. Escape velocity of a body from Earth is 11.2 kilometer per second. If the radius of a planet be one third the radius of the Earth and mass be one sixth that of Earth, the escape velocity from the uh, plate is, it's not here plate, it's planet. Okay. Now, according to this question, so this is from the chapter of gravitation. Now, since the escape velocity is given as 11.2 kilometer, escape velocity means the formula for escape velocity is what? Under root 2 gm over r, and it is given as 11.2 kilometer per second. According to question, this is Earth and there is a planet. Okay, the radius of a planet is, let us say, radius of the planet according to question, it is one third of the radius of the Earth, and mass of the planet is equals to one sixth of the mass of the Earth. We have to find the escape velocity from the planet. Okay. Now, since the escape velocity of the Earth is equals to under root 2g me over re. Okay. And the escape velocity of planet will be under root 2g mp over rp. Now putting the values of rp and mp from equation 1 and 2 in this equation vp, so we will get, first divide ve by vp. So dividing ve by vp will be equals to what? Under root 2g cancels out each other. It will be equals to under root of me over re divided by under root of mp over rp. So it will be equals to under root of me over re divided by under root of mp. mp is what? 1 by 6 of me, and rp is what? 1 by third of re. So this under root me, under root re cancels out each other. 3 2s are 6. So thus ratio of VE over VP, it will be equals to root 2. Therefore, escape velocity of planet VP, it will be equals to VE by root 2, and VE is given what? 11.2 kilometer per second. So it will be 11.2 divided by root 2. So VP will be equals to 7.9 kilometer per second. Okay. So the correct option is, option D, 7.9 kilometer per second. Okay. Now moving towards our next question 43. According to this question, a particle of charge minus q and mass m moves in a circle of radius r around an infinitely long line charge of linear charge density plus lambda. Then the time period will be given as. So this question is from the chapter of kinematics. Okay. This is from the chapter of kinematics. Okay. According to this question, there is a linear charge density, let us say, plus q charges over the uniformly distributed over this linear charge density, and According to this, let us say there is a particle whose charge is minus q and it is rotating around this linear charge density infinitely long wire having linear charge density plus lambda and its mass is m. Okay. Now, since we know that it is revolving around this infinitely long wire, so the force, it will be equals to centripetal force, it will be equals to mv square over r. Okay. Since we know that v equals to what? R omega. This is what? Centripetal force. Okay. V equals to R omega. So from this, F will be equals to M R square omega square over R. Okay. So it will be equals to M R omega square. The force will be equals to M R omega square. Okay. Now, this force for an infinitely long wire, the electric field is equals to 2k lambda over r. This is the common formula for an infinitely long current carrying wire. Long current carrying wire, the electric field for this is given by current carrying wire. Electric field is given by E equals to 2k lambda over r. So, and since force is equals to Q into E, charge into electric field. So force will be equals to from this 2k 2k lambda 2k lambda Q over R, E into Q over R. So from this we write F here 2k lambda over R into Q. It will be equals to M R square omega square over R means this mr omega square. Okay. Now we know that omega equals to 2 pi over t. Okay. So t will be, now putting the value of omega from here. So we get 2k lambda over r into q. It will be equals to mr omega square means 2 pi over t whole square. Okay. Now 2k lambda over r into q. It will be equals to m r 4 pi square over t square. So 2 2s are 4. So we get t square is equals to 2m pi square r square over k lambda into q. Okay. So t will be equals to pi r under root 2m upon k lambda q. So the correct option is t equals to pi r under root 2m. T equals to pi r under root 2m. Okay. To match with the options, let us multiply the numerator and denominator by 2. So we will get 2 pi r under root m over 2k lambda q. This is our final answer. So the correct option is what? Option B, that is t equals to 2 pi r under root m 2k lambda q. Now next question 44. If mass is written as m equals to k c raised to the power p g minus 1 by 2 h 1 by 2, then the value of p will be. So this question is from the chapter of units and measurement. According to this, we have to find the value of p. Okay. So let us first write LHS. LHS is given as what? Mass m. So it means its dimension are m, L0 and T0. Okay, LHS. Now writing RHS. RHS is K is the constant, leaving K. C raised to the power P. C raised to the power P. G minus 1 by 2 and H 1 by 2. Okay. Here C is what? Speed of light, G is the gravitation, and H is the Planck's constant. Okay. So C is the speed of light, means it is the speed. So its dimension are what? LT minus 1. Since it is a speed, so we write C raised to the power P as LT minus 1 P. Okay. G is the gravitation, minus 1 by 2. So it will be gravitation is what? Since force equals to G m square over R square. So from this G will be F into R square over m square. So we can write G as here F R square over m square raised to the power minus 1 by 2. Okay. Now dimension of force. Force dimension are what? M L T minus 2. This is R radius square, means it is length. So L2 over M2. Okay. So it will become M minus 1 L cube and T minus 2 whole power minus 1 by 2. Okay. Let us say this is 1, this is 2. And the third one is what? Planck's constant H. H raised to the power 1 by 2. Since E equals to H nu, Planck's constant into frequency, so H will be E by nu, and E dimension are M L square T minus 2 over frequency. Frequency is what? 1 over T. So we write T minus 1. Okay. So it will be M L square T minus 2 plus 1. So it will become ml square T minus 1. Okay. So H1 by 2 will be equals to ml square T minus 1 whole power 1 by 2. Now putting equation 1, 2 and 3 all together. So we get the RHS as what? LT minus 1 P. K is the constant, LT minus 1 P. Then second one is M minus 1 L cube T minus 2, M minus 1 L cube T minus 2 raised to the power minus 1 by 2. And this third one, M L square T minus 1 whole power 1 by 2. Now solving it, we get RHS as K is the constant, L P plus minus 3 by 2 plus this 1. Okay. Then T minus P. This will be minus minus plus 1. And then this will be minus 1 by 2. Okay. And then M. M will be minus minus plus 1 by 2. And this is also plus 1 by 2. Okay. So we get RHS as K L minus 3 by 2 plus 1 means P minus 1 by 2. Okay. Then T is what? Minus P plus of 1 by 2. And M is what? 1. And what is LHS? LHS is M L0 T0. Okay. LHS is what? M L0 T0. So we have to find the value of P. Now comparing the powers of L from RHS and LHS. So P minus 1 by 2 will be equals to 0. This implies that P equals to 1 by 2. So our correct answer is P equals to 1 by 2. Option A. Now next question 45. In the given circuit, the voltage across load resistance RL will be. So this Question is from the chapter of current electricity. Okay. Current electricity. Now, in this question, this is diode made up of germanium. This is silicon diode made up of silicon. According to the NCERT books, okay? According to the NCERT books, the germanium diode, its voltage is given as 0.2 volt. But according to when we Google it, uh, its voltage is given as 0.3 volt. Okay, so if we use 0.2 volt, its answer will be different, and if we will use 0.3 volt, its answer will be different. So according to me, in question, the voltage should be given, but here the voltage is not given, so we will use a standard value, that is 0.3 volt, and for silicon it is 0.7 volt. Okay, now the total voltage is 15 volt. So always the voltage is distributed according to the ratio of the resistors. So if 0.7 plus 0.3 means 1 volt is distributed here across the two diodes, so the remaining 14 voltage is here. Okay, now in these two resistors, from the Ohm's law, V equals to IR. So V is what? So here current will be I equals to V over R. So V is what? 14 volt over total R. These two are in series. So this will be 1500 plus 2500. So it will be 14 over 4000. Okay. Now so current will be here 14 over 4000 ampere. Okay, so the question is asking about the voltage across the load resistance RL. So the voltage across RL will be, again using Ohm's law, V equals to IR. So it will be I current is what, 14 over 4000, and R 2.5 kilo ohm means 2500. So solving it, we get 5 5s are 25, 5 8s are 40, 2 7s are 14, 2 4s are 8. So it will be 35 over 4. So we get 35 over 4, but 4 8s are 0.75. So the correct answer is 8.75 volt. Okay. Now next question 46. If 3 moles of monatomic gas whose gamma is given as 5 by 3 is mixed with 2 moles of a diatomic gas, gamma is 7 by 3. The value of adiabatic exponent gamma for the mixture is, okay. First of all, this question is from the chapter of kinetic theory of gases. Kinetic theory of gases. Now, according to question, 3 moles of monoatomic gas are mixed with 2 moles of diatomic gas. Okay. So first of all, we have to find F, degrees of freedom for this mixture. So degrees of freedom, its formula is N1 into F1 plus N2 over F into F2 over N1 plus N2. Okay. Since there are monatomic and diatomic, so for monoatomic, always N will be equals to 3. And for diatomic, N is always 5. And for if the question is asked about a triatomic, so for triatomic, N value is 6. Okay. Now this question is for monatomic and diatomic. So there are 3 moles of monatomic. 3 moles means N1 means 3. N1 means 3. And 2 moles of diatomic means here N2 is 2. Okay. And here N means F. Generally, I am writing N for F. Okay. Degrees of freedom. So the mixture of the degree of freedom for this whole mixture will be 3 into F1. F1 is what? Monatomic. So for monatomic, it is 3 plus N2 means 2 into F2. F2 is for diatomic. For diatomic, degree of freedom is 5 into 5 over N1 plus N2 means 3 plus 2. So the F mixture will become 3, 3, 9, 5, 2, 10 over 3 plus 2, 5. So it will be 19 over 5. Now, the question is asking about the value of the adiabatic exponent gamma for the mixture. So its formula, it is having a direct formula. So gamma for the mixture will be equals to 1 plus 2 by this F mixture, okay? So it will be equals to 1 plus 2. This F mixture is 19 over 5 means 19 over 5. So it will be equals to 1 plus 10 over 19. So it means it is 19 plus 10, 29 over 19. So it will be equals to 1.52. So gamma mixture it will be equals to 1.52. So the correct answer is option C, 1.52. Now next question 47. Three blocks A, B, and C on a horizontal smooth surface by a force of 80 Newton, okay, as shown in the figure. The tensions T1 and T2 in the string are respectively. So this question is from the chapter of kinematics. Now, since there are three blocks, A, B, and C, okay, and the total force is F equals to 80 Newton. So if T1 tension is acting in the string A and T2 is acting in the string B, so the total acceleration will be, since force equals to mass into acceleration. So force is of 80 Newton and mass is what? 5 plus this 3 plus 2. So it will be equals to 5, 3, 8 plus 2, 10. So 10 into A. So the acceleration acting on this hole will be equals to 80 by 10. It will be equals to 8 meter per second square. Now the question is asking about the tensions T1 and T2. Okay. So for T1, it will be equals to mass into acceleration. So T1 will be equals to mass is what? 5 into acceleration is what? 8. So T1 is 40 Newton. Okay. And T2 again mass into acceleration. Now for T2 mass will be this plus this. This T2, for this T2, the total mass will be this mass plus this mass, means 5 plus 3 equals to 8. And acceleration is what? 8. So it will be 64 Newton. So the correct answer is 40 Newton and 64 Newton means option A. Okay. Now next question 48. When a potential difference V is applied across a wire of resistance R, it dissipates energy at a rate of W. If the wire is cut into two halves and these halves are connected mutually parallel across the same supply, then the same supply, the energy dissipation rate will be. So this question is from the chapter of current electricity. According to this question, there is a resistor R having resistance R and a potential difference V is applied across it. Okay. So its energy rate is W. W means V square over R. This is a very basic formula. And then these are cut into two halves. Always remember, these are cutting into two halves. Okay. Means they are generally cut. They are not elongated. They are cutting into two halves. Okay. And then these halves are connected mutually parallel across the same supply. Means this will be R by 2. This will be R by 2. The question is saying that they are cut into two halves, not stretched. Okay, not stressed. They are cutting into two halves and they are then mutually connected across the same supply. So for this, the work will be, means the energy will be V square by R. V square means V square over R means here these two connected in parallel. So R will be R by 2 into R by 2 over R by 2 plus R by 2. So this will be equals to r square by 4 over r, means it will be r by 4. So now writing here r by 4. So W dash means energy will be equals to 4 V square over R. Initially, W will is V square over R. So new W dash will be equals to 4 into W. So the energy dissipation rate will be 4 into W, means option D. Okay. Now next question 49. Match list 1 with list 2. Okay. So these are the Maxwell's equation. Maxwell's equation. So student, the same question has been asked in 29th Jan shift 1 paper, okay? Same question, exactly same question has been asked in 29th Jan shift 1 2024. Okay. Now, the first one is Gauss law of magnetostatics. Gauss law of magnetostatics means integration of B dot dA is equals to 0, means the total magnetic flux passing through a closed surface is always equals to 0. This equation also says that single dipole means single monopole does not exist. Single monopole does not exist means the uh, there will be always dipole, no monopole, means single north pole or single south pole does not exist. Always they exist in a pair, means a bar magnet will always have north pole along with its south pole. Okay. And the second, so this A match with B, this second. Now the B is Faraday's law of electromagnetic induction. This Faraday's law of electromagnetic induction is what? The line integral of electric field is equals to rate of change of magnetic flux, and this magnetic flux phi is equals to B dot A. So this integral of E dot dl will be equals to minus B or minus A. So we can write B del A over del T, or we can write minus A del B over del T. Okay. So this B matches with third. Now C is Ampere's law. Ampere's circuital law. According to this law, the integration of line integral of B dot dl magnetic field is equals to minus mu naught times the total current through the closed surface. Okay. So the Ampere's law matches with the fourth option. And D is Gauss law of electrostatics. Gauss law of electrostatic means the total electric flux passing through a closed surface is equal to 1 over epsilon naught times the total charge enclosed by the surface. So the fourth D matches with the option A. So the correct answer is option D. Now next question 50. Projectiles A and B are thrown at an angle of 45 degree and 60 degree with verticals respectively from the top of a 400-meter tower. Okay. If their ranges and times of flights are same, the ratio of the speed of projection will be, we have to find their ratio of the speed of the projections. Okay. Now, since this question is from the chapter of kinematics, according to this question, let us say this a body is thrown at an angle of 45 degree with the vertical, and another body is, this is body A, and another body B is thrown with an making an angle of 60 degree with the vertical. Okay, this is another body B. Okay, this is making the body, let us say this is A, this is B. The body A is making an angle of 45 degree with the vertical, and the body B is making an angle of 60 degree with the vertical. Okay, its speed is UA, its speed is UB. Since according to question, their ranges and time of flights are same, Since R1 is equals to R2, ranges are same means UA cos theta means UA cos 45 degree making with the horizontal, huh? It will be equals to UB cos 30 into T also. Time of flight into T. Into T. Okay. So according to this, UA upon UB will be equals to cos 30 over cos 45. We have write cos 30 here and cos 45 since the A and B projectiles A and B are making an angle of 45 degree with the vertical. So the range angle is calculated with the horizontal, na? So if it is making 45 degree with the vertical, so with the horizontal it is making 90 minus 45 means 45. I mean, and if it is making 60 degree with the vertical, so with the horizontal it is making 90 minus 60 means 30. So UA over UB will be cos 30 over cos 45. Okay. Now, if T1 is equals to T2, okay. If T1 is equals to T2 from second equation of motion, S for vertical motion, Sy will be equals to Uyt plus half it Ay into T square. Okay. Since T is same, U is same, since T is same, this displacement is same. Displacement is what? 400 meter. So both A and B, this time is same, displacement is same, and acceleration in downward direction is same. So Uy will be same. So for this, Uy1 will be equals to Uy2. Since Uy1 is equals to Uy2, then Ua cos 45 degree will be equals to what? Ua cos 60 degree for vertical motion, na? Ua cos 45 degree will be equals to Ua cos 60 degree. But if we are using these two equations, first and second, there will be two answers for a given question, and this is not possible. So the correct answer will be none of the above. So the next question is 51. A power transmission line feeds input power at 2.3 kilovolt to a step-down transformer with its primary winding having 3000 turns. The output power is delivered at 230 volt by the transformer. The current in the primary of the transformer is 5 ampere and its efficiency is 90%. We have to find the output current. Okay. So this question is from the chapter of electromagnetic induction and alternating currents. Induction and alternating current. So in this question, we are given with the input power and the current having an efficiency of 90%. So the general formula of power is what? This is input power, okay? Means PI. It is equals to voltage into current. So voltage is given as 2.3 kilovolt into current is given 5 ampere and efficiency is of 90% means 90 over 100. So it is equals to 2300 into 5 into 0.9. This is input power, okay? And so output power will be equals to same voltage into current. Voltage is what? Output voltage is 230 volt. So 230 volt into current. We have to find this output current means I. And we know that in a primary or secondary transformation, the input power is equals to output power. So PI will be equals to P out. So 2300 into 5 into 0.9. It is equals to 230 into I. So I will be equals to 0 cancels 23 10. So 10 into pi 50 into 0.9. it will be equals to 45 ampere. Okay, current will be 45 ampere. Now next question. A big drop is formed by collapsing 1,000 small identical drops of water. If E1 be the total surface energy of 1,000 small drops of water and E2 be the surface energy of the single drop of water, then we have to find the ratio of E1 to E2. This question is from the chapter of properties of solids and liquids. According to this question, there is a big drop, and from this big drop, thousands of identical small drops are forming. Okay, thousands of. So let us say is capital R be the radius of the big drop. Okay, and small r be the radius of thousands of small drops. Okay, now the volume of the one big drop will be equal to the sum of the volume of all the small drops. Okay, so volume of big drop will be, since a drop is in the form of a square, so volume of big drop is 4 by 3 pi r cube. It will be equals to 4 by 3 pi small r cube into 1000. Okay, so capital R 4 by 4 by 3 4 by 3 cancels out each other, pi cancels out each other. So capital R cube will be equals to 1000 into small r cube. Okay, so capital R will be equals to 10R. Okay, the relation between capital R and small r is capital R equals to 10R. Now we have to find the ratio of E1 and E2. Now let us say E1 is the energy of 1,000 small drops, means having a small radius r. Okay, so its energy E1 will be equals to 1,000 into area pi r square into surface tension S, and E2 be the energy of the big drop having radius capital R. So E2 will be equals to its area 4 pi capital R square into S. Since capital R is equals to 10R, so we will write 4 pi into 10R whole square into surface tension S. So it will be equals to, so E1 by E2 will be equals to 1000 into 4 pi R square into S over 4 pi into 10 power 2 into r square into s. S has cancelled out in the r square cancels, 4 pi cancels, and 10 raised to the power 2 means this 2 0 cancels. So E1 over E2 will be equals to 10 over 1. Now comparing this with the given statement, x ratio 1 means x over 1. So the value of x is 10. This is our final answer. Okay. Now next question 53. Two disk of moment of inertia I1 equals to 4 kg meter square and I2 equals to 2 kg meter square about their central axis and normal to their planes, rotating with angular speeds 10 radian per second and 4 radian per second respectively, are brought into contact face to face with their axis of rotation coincident. The loss in kinetic energy of the system is. So this question is from the chapter of rotation motion. Now this question has been asked in the first shift of 30th Jan 2024 paper. Okay, this paper is of second shift, and same question has been asked in the first shift also. Okay, now there are two disks of moment of inertia I1 and I2. Let us say these are two disks I1 and I2. So I1 moment of inertia of first disk is given as 4 kg meter square and I2 is 2 kg meter square. ठीक है, and their angular speeds are omega 1 is 10 radian per second and omega 2 is 4 radian per second. Okay, into the law of conservation of angular momentum, I1 omega 1 plus I2 omega 2 will be equals to, when they are brought in contact face to face with their axis of rotation coincident, means these two disks, when these two disks are brought in contact with each other, they form a single disk having the combination of these two moment of inertia, means these two coincidence with each other. Okay, so I1 omega 1 plus I2 omega 2 will be equals to I1 plus I2 into omega naught. Omega naught will be the final angular speed when these two this coincident with each other. Okay, so now I1 is what? 4, omega 1 is 10, plus I2 is 2, omega 2 is 4, equals to I1 plus I2 means 4 plus 2, 6 into omega naught. So omega 6 omega naught will be equals to 40 plus 8, 48. So omega naught will be 8 radian per second, means when the two disks coincident with each other, at that time their combined angular frequency will be 8 radian per second. Okay, now it is asking about the loss in the kinetic energy, means first we have to find the combined energy of these two disk, means having moment of inertia I1 and I2, and when they both combine to form a single disk, we have to find the energy of that also, then subtracting this E1 minus E2. Okay, now E1 will be equals to half I1 omega 1 square plus half I2 omega 2 square. It will be equals to half. I1 is what? 4 into omega 1 is 10 square plus half I2 is 2 into omega 2 is 4. 4 means 4 square. So solving it, we get 10 and 100 into 200 plus 4, 416. So we get 216 joule. Okay, E1. Now E2 will be half I1 plus I2 into omega naught square. So it will be equals to half. I1 is 4, I2 is 2, omega naught is 8 from equation 1 to 8 square. So it will be 1 by 2 into 6 into 64. 2, 3 is 6. So it will be equal to 4, so 12 carry 6, 8 and 192 joule. So the loss in energy delta E will be equal to 216 minus 192. It will be equal to 24 joule. Okay, so the loss in energy is 24 joule. Now next question 54. In an experiment to measure the focal length f of a convex lens, the magnitude of the object distance x and the image distance y are measured with reference to the focal length. Okay, the y-x plot is shown in the figure. We have to find the focal length. Okay, so this question is from the chapter of optics. Since we are given with reference to the focal point of the lens, okay, so we have to consider this reference of the focal point. According to this, using the general formula for finding the focal length, 1 over b plus 1 over u equals to 1 over f, sorry, minus 1 over u equals to 1 over v. V is what? F plus 20, because we are using with reference to focal point, na? With reference to focal point. So 1 over f plus 20 minus, since the object is on the left hand side, so it will be minus of f plus 20. It will be equals to 1 over f. Now solving this, we get 1 over f plus 20 minus minus plus 1 over f plus 20, it will be equals to 1 over f. So 2 over f plus 20 will be equals to 1 over f. So 2f equals to f plus 20 means f is equals to 20. Okay. We can use another formula for this also. The another formula is x1 into x2 equals to f square. x1 is what? In y there is 20, in x there is 20. Okay, so x1 is 20 means x is 20 and y is also 20 equals to f square. This is the short trick to solve this question. So f will be equals to under root of 400. So it is 20 centimeter. Okay. Now next question 55. A vector has magnitude same as that of A equals to 3i plus 4j cap, 3 iota cap plus 4j cap, and it is parallel to B, 4 iota cap plus 3j cap. The x and y components of this vector in the first quadrant are x and 3 respectively. Okay, we have to find the x component. Okay, so this question is from the chapter of kinematics. Okay, according to question, there is a vector whose magnitude is given by this A 3 iota cap plus 4 j cap. Okay, and it is parallel to B equals to 4 iota cap plus 3 j cap. Now, let us say there is a vector x. Okay, this vector is parallel to this vector B. So first we have to find the unit vector along B. Let us say x is a vector parallel. Okay, in this case, A is the vector, na, which is parallel to B. Okay, A is a vector parallel to B. So, the unit vector along B. At first, we have to find the unit vector along B, means this. So, unit vector along B will be equals to this 4i plus 3j over modulus of B, means B over B. Okay, so it will be 4i plus 3j over under root of their magnitude 16 plus 9. It will be equals to 4i plus 3j over 5. Okay. This is the unit vector along B. Now there is a vector. Let us say this vector is S. This vector has a magnitude of this and it is parallel to this vector B. Okay. Now, so this vector X will be equals to modulus of A into unit vector B. So it will be equals to modulus of A is what? 9 plus 16 into unit vector B. Unit vector B is what? 4 iota cap plus 3 j cap over 5. So it will be equals to 5 into 4 iota cap plus 3 j cap over 5. So this 5 cancels out each other. So X will be 4 iota cap plus 3 j cap. Now comparing it with the given x and 3 means x iota cap plus 3 j cap. So the value of x is 4. This is our final answer. So the next question is 56. The current of 5 ampere flows in a square loop of sides 1 meter is placed in air. The magnetic field at the center of the loop is this much. We have to find the value of x. So this question is from the chapter of magnetic induction of current and magnetism. Current and magnetism. Okay. So now according to this question, there is a square loop. Okay. Each side of the square loop is of 1 meter. Now, let us say this is a square A, B, C, D. We have to find the magnetic field at the center O due to this whole square loop. And the current flowing in the square loop is of 5 ampere. Okay. So, let us draw the line from center to the sides of the square loop, and this is the perpendicular. We know that each corner angle of a square is of 90 degree. So this will be 45 and 45. Since a perpendicular bisector divides the line into equal angles, na, so this will be 45 and this will be 45. Now, if we will find the magnetic field due to this part, means due to this side AB of the square loop, and if we will multiply this magnetic field by 4, we will get the net magnetic field due to this square loop. Okay. Now, let us find the magnetic field due to this side AB. Let us draw it as like this. This is point A, this is B, this is O. Let us say this distance is R. Okay. Now this is angle alpha 1, which is of 45 degree. This is angle alpha 2, which is of 45 degree again. Now in such type of question, the magnetic field is given by B equals to mu naught over 4 pi I over this distance R into sine alpha 1 plus sine alpha 2. Okay, now, so B will be mu naught over 4 pi into I over R. R is here what? This distance is R. This is 1 meter. So this distance will be 1 by 2. Okay. And sine alpha 1 means sine 45 degree plus sine 45 degree. Okay. So it will be equals to B will be equals to mu naught over 4 pi into 2i. Sine 45 is 1 by root 2 plus sine 45 is 1 by root 2. So it will be equals to mu naught over 4 pi into 2i into 2 by root 2. So it will become mu naught over 4 pi into 2i into root 2. Okay, this is due to side AB. Now the net magnetic field due to whole square loop at the center O will be 4 into this BAB. So it will be equals to 4 into mu naught over 4 pi into 2i into root 2. So this mu naught is what? 4 pi into 10 to the power minus 7 into 2i into root 2 over 4 pi. This 4 pi cancels. So it will become 4 into 2, 8 root 2 into 10 to the power minus 7 I. And I is given as 5 ampere. So putting the value of I, we get B net magnetic field will be 8 root 2 into 10 to the power minus 7 into I 5. So it will become 40 root 2 into 10 to the power minus 7 Tesla. This is the final answer. Okay. Now next question 57. Two identical charge pairs are suspended by a string of equal lengths. Okay. The string makes an angle of 37 degree with each other. When suspended in a liquid of density this, the angle remains same. If the density of the material of this pair is this much, we have to find the dielectric constant of the liquid. Okay. So this question is from the electrostatics chapter. Now, according to this question, let us say there are two identical charge pair. Okay, let us say one pair is this, another pair is this, and they are suspended by this string, and these string have equal length. The string makes an angle 37 degree with each other. Let us say this angle is 37 degree. When suspended in a liquid of density this much, the angle remains the same. Okay, the angle remains the same. Okay, let us say this is sphere A, this is sphere B. Now if we resolve these into two components. Let us say the tension in this string is T, and here also the tension is T. Now resolving into two components, the downward weight will be what? Mg, and upward direction will be FB force due to spare. Let us Fs, okay, due to spare. Now here Fe force, and here will be this is if consider this theta, so this will be T sine theta, and this will be T cos theta. Okay, now using the basic equations, that T cos theta will be equals to mg, downward direction weight, okay, and T sine theta will be equals to Fe, this force. So from these two equation, first and second, dividing equation 2 by equation 1, okay, so we get uh, T sine theta over T cos theta equals to Fe over mg. T cancels, so tan theta is equals to Fe over mg. Okay. Now m is the mass, g is the gravity. Okay. So let us say this is equation 3. So density equals to what? Mass over volume. So mass will be density into volume. So putting this value of m in this, so tan theta will become Fe over rho. Let us say this is for sphere, okay, into volume into gravity. Let us mark this equation as 4. According to question, the density of the material of the sphere is 1.4 gram per centimeter cube. So this is the density of the sphere. Okay. Now we can write when the another equation, when the density of water is given, means liquid is given. When it is suspended in a liquid, its density is this much. Okay. And it is also saying that the angle remain the same. So for this, tan theta will be same. So tan theta will be equals to Fe over, now there will be introduced a new dielectric constant K over density of sphere minus density of that liquid into its volume into gravity. Okay, this is equation 5. Now dividing equation 4 by 5. If we divide equation 4 by 5, so tan theta cancels, Fe cancels, V and G cancels, V and G cancels. So we get so what we get, rho S equals to rho S minus rho L into K. Okay, and rho S, density of sphere, is what? 1.4 gram per centimeter cube. 1.4 gram per centimeter cube, and density of sphere minus density of liquid means 1.4 minus density of liquid is 0.7. So 1.4 minus 0.7 into dielectric constant K. So 1.4 equals to 0.7 K. So therefore K is equals to 2. So our answer is K equals to 2. Okay. Now K equals to 2. Now next question 58. A simple pendulum is placed at a place where its distance from the Earth's surface is equal to radius of the Earth. If the length of the string is 4 meter, then the time period of the small oscillations will be. So this question is from the chapter of oscillations and waves. Oscillations and waves. So this question is saying, okay, let us say this is Earth, okay? And a simple pendulum. Here it is a simple pendulum. Let us say this pendulum is suspended, is at a distance equals to the radius of the earth. Let us say its height h is equals to radius of the earth r. If the length of the string is 4 meter, if this length of the string, if L is equals to 4 meter, we have to find the time period of the small oscillations. Since we know the general formula for the time period of the simple harmonic motion is T equals to 2 pi under root L over G. This is the formula for finding the time period of a small oscillation of simple harmonic oscillator. Okay, now the gravity at a distance, at a height h, the formula for gravity is gm over r plus h square. This is the formula for a body when it is placed at a height h from the surface of the earth. G equals to gm over r plus h square. But here h is equals to r, so g will become gm over r plus r whole square. So g will be equals to gm over 4 r square. And since the gravity at the surface of the earth is equals to gm over r square, let us say this is g naught. So gm over r square is what? G naught by 4 means the gravity at a height h from the surface of the earth will be equals to G naught by 4. Okay. Let us mark this as equation 1. This is as equation 2. Now putting the value of G from equation 2 in equation 1. So we get T is equals to 2 pi under root L over G naught by 4. So T will become 2 pi under root, and L length is given as 4 meter. So it will be equals to 4 into 4 over G naught. So T will be equals to 2 pi into 4 into under root of G naught, and G naught value is given as pi square. G is given as pi square, so putting value of G naught as pi square, so we get 2 pi over 4 into pi upon pi. Pi cancels, so we get T equals to 8 seconds. This is our final answer. Now next question 59. A point source is emitting sound waves of intensity 16 into 10 to the power minus 8 Weber per meter square at the origin. The difference in intensity at 2 points located at distance of 2 meter and 4 meter from the origin respectively will be. Okay, so we are given with the intensity watt per meter square. Different in the intensities we have to find, and we are given only with the distances. There is something missing in the question, so I think this question is incomplete and it is wrong. Since this question is incomplete, okay, so we'll not solve this question. Now next question 60. Two resistance of 100 ohm and 200 ohm are connected in series with a battery of 4 volt and negligible internal resistance. A voltmeter is used to measure voltage across 100 ohm resistance, which gives reading 1 volt. The resistance of the voltmeter must be. So this question is from the chapter of electronic devices. Now let us draw the circuit diagram according to this. There are two resistances. This is 100 ohm and this is also 200 ohm. Okay, they are connected in series with a battery of 4 volt. Let us say they are connected with a battery of 4 volt. Okay, now a voltmeter is used to measure voltage across 100 ohm, which gives reading as 1 volt. Okay, uh, the reading of voltmeter here is 1 volt. And the resistance of the volt, we have to find the resistance here across this voltmeter having a voltage of 1 volt. Okay, let us say we have to find the value RV. Okay, now since the whole circuit having a voltage of 4 volt, and from this 4 volt 1 volt is across the resistance 100 ohm, so remaining 3 ohm will be here across the resistance of 200 ohm. So the current flowing through this circuit will be using Ohm's law, V equals to IR. So I will be V over R. V over R means 3 over 200. Okay, 3 over 200 ampere. Now, these two are in parallel. So, the using parallel formula and also using Ohm's law, okay? At first, we will use the parallel formula. So, 1 over RV plus 1 over 100 equals to what? This 1 over RV plus 1 over 100. It will be equals to 1 over R. 1 over R means R equals to V over I. So, V over I means V over I. Voltage is 1 volt over current is 3 into 200. Okay. 200. So, it will be equals to RV plus, no, okay, solving it like this. So 1 over 100, sorry, 1 over RV will be equals to 200 over 3 minus 1 over 100. V over 100, no, V over R. So it will be equals to, something is wrong. Okay, 1 over RV plus 1 over 100, it will be equals to 1 over R. R means V over I. So R will be equals to V is what? V is 1 volt over I is 3 into 200 and we have to write here 1 over R. Okay, means 200 by 3. Okay, 1 into 3 over 200. It is not 200 by 3. It will be 3 over 200. Okay, this is wrong. So we get 1 over RV will be equals to 3 over 200 minus 1 over 100. So 1 over RV will be equals to 203 minus 2. It will be equals to 1 over 200. This implies that RV is equals to 200, means the resistance of the voltmeter having voltage 1 volt is 200 ohm. Okay, this is our final answer.